Everybody on three. 1, 2, 3. I can identify the greatest common factor and least common multiple of two numbers. One more time. 1, 2, 3.
I can identify the greatest common factor and least common multiple of two numbers.
All right. So today's lesson is going to be revisiting a couple concepts that you guys covered when you were in elementary. Oh, back in 3rd and 4th grade. And you're going to see how it's fairly simple. And today will probably be the easiest lesson out of the entire second semester. So enjoy it. You don't need a fair model. Yes. All right. So we're identifying greatest common factor and least common multiple. Now, when you were in elementary, your teacher, focus please, introduced these two concepts like really far apart, like maybe 2 months apart. But I'm going to show you a strategy today that you can do both of them at once, and it's going to be a lot faster and a lot easier. But of course, whatever we do with regular numbers, we have to do with what? Algebra. Okay? And we're bringing back polynomials. Yeah, let's go. Okay. So now, the other thing, I don't know if you guys noticed, the prayer model that we usually use for our Cornell notes, that's mainly used in language arts. And it's more like an organizational tool. You guys might not use it as much, but there's other places that do. The other tool that I'm going to use today that's the language arts tool is a Venn diagram. Who's been using Venn diagrams? Yeah, sometimes you use those to compare and contrast two different items. So I'm going to show you first how to use a Venn diagram for those of you that don't know how to use one. Here it goes. I'm going to zoom out really quick. So here, I'm going to use a Venn diagram to compare myself to Michael Jordan. Be nice. Bam, let's go. No. Here goes. So the question is, what do I have in common with Michael Jordan? So I'm going to create a Venn diagram. This circle's for Mr. Jordan. This is for me. Here it is. So let's start with Michael Jordan. Michael Jordan is tall. Well, I'm not that tall. Michael Jordan is a professional basketball player. I am a teacher, professional teacher. Okay. No, I'm not. No, the one that was a professional basketball player was Mr. Cavanier. Yeah, he played pro. Yeah. He played here for one of those secondary leagues, but then he got a contract to go play professional in Mexico. Yeah. You're like, oh, really? There's professional players from the NBA that go over there, if you guys didn't know. Yes, here goes. What else does Jordan have? Let's see. Jordan is rich. I'm not rich. But one thing that got me interested in Michael Jordan, aside from being awesome on the basketball court, my favorite subject in school was math. So was his. Yes, believe it or not, his favorite subject was mathematics. Now, before I finish that part of the Venn, a quick insight on Jordan. When he was playing in the NBA, he affected the U.S. economy because of what he sold, the products that he sold on the court and off the court. Kind of like, for example, I think I already told you the story. Back then, there was a university. Well, before I go to the university, you know how the weather here in the valley, when it gets in the summer, sometimes there's days that are very humid. Yeah. That sometimes you're in the morning before being dropped off somewhere, you're riding in your car with air conditioning, and all of a sudden you get off, your shades or your glasses get fogged up because of the humidity. In Florida, that's how the humidity is during the summer most of the time. So therefore, over there, they have a university, and football players would lose a lot of liquids as they practice. So therefore, one of their trainers, they said, they got the idea, and everybody's seen this in hospitals where when people go in, they put an IV with something like that full of liquid, right? Well, that liquid is a balanced combination of salt, sugar, and water. So this trainer said, you know what? For them to get fluid back in a little bit, refreshen and get rehydrated, I'm going to create something for them to take. I'm going to make salt, sugar, water, but I'm going to put citrus, like orange, because they're known for orange, right? And then all of a sudden, mixed it up. It was orangey, and he gave it to the players, and they got replenished really fast, and they were winning their games. Now, who is the mascot for Florida? The Gators. And since it helped them, it was called Gator Aid.
Oh my God!
So they combined that, and now it's known as Gator. However, when they started to try and commercialize that, a lot of people didn't want to use it. It was mainly used in college circles. So guess who got a hold of somebody? Michael Jordan. And all of a sudden he made a commercial for it and forget about it. After that, it just blew up. They started selling overseas and so on and so forth. Well, guess what? Since he was good with numbers, they made a good contract. So now anytime they sell something like that, who gets paid? Exactly. Especially when it first started, it just blew up, and that's just one example. The other example is Nike. Now let me show you Nike, how that came along. There was this runner in college that he ran track, and everybody knows the track is about this size, right? And that big or something like that. And he would run. There it is. Not that. There it is. And all of a sudden the trainer wanted to make him a little bit faster for a competition. So he designed him some shoes. So then all of a sudden, when he would come around, the trainer wanted to find out, well, what logo can we design? So he would notice that he would start picking up speed at about here, and instead of staying like here, he would go like a little bit of wide, and then he'll come back over here. And then all of a sudden they made a shoe called Nike. So therefore, when Jordan started signing going from college to pro, he wanted to sign with Adidas because Adidas was the big thing. Back then there was a rap group called Run DMC, and a lot of them, all the rappers and the break dancers, LL Cool J, all them used Adidas. And they use those jumpsuits, kind of like the one Maria has, but the full thing, like the sweats and also the jacket. They used to use those to break dance. I used to break dance. Did everybody know that? No? 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 Oh, let's go. So, I'll put it away. All right, so, anyways, long story short, Jordan, they didn't want to give Jordan a contract for the amount that he wanted. Once again, good with numbers, get it? So he was approached by this small company, very small company known as Nike, and the rest is history. And now everybody buys Nike. You see what I'm saying? And that's part of Michael Jordan knowing how to use numbers to invest in himself as he continues his professional career. Now let me go back to our Venn diagram. So once again, what is the one thing that Jordan and I have in common? Favorite subject is math. Now, did I write favorite subject is math 2 times here in the center? I only wrote it once. Keep that in mind because right now we're going to use numbers to show you how to use the Venn diagram to find the GCF and LCM. Okay? All right. Write example number 1 on your paper, please. Example 1. Example 1 says, what is the greatest common factor and least common multiple of 24 and 36? Copy that. All right. So check this out. Writing utensils down, look up to the screen. Now, I'm going to do this a little bit different than the way you were probably approached. Okay? So here we go. The first thing is I'm going to start off by writing my first 5 prime numbers. 2, 3, 5, 7, and 11. Don't write anything down, just pay attention. Oh my goodness. So you're saying, let's see, refreshing my memory, Mr. Q, why are these prime? Because they can only be divided by themselves and 1. For example, is 6 a prime number? Let's see, divided by 1 in itself? Yes, it can be divided by 1 in itself. But it also could be divided by what? 2 or 3. So is this a prime? No, because it has more than 2 factors. This one can only be divided by 1 and 2, this one by 1 and 3, and so on and so forth. Everybody understand? All right, so with that said, now that we have that, I'm going to write 24 and 36, and you're just paying attention. First thing that I'm going to do is called a factor tree. Remember that. Okay, and your teacher says, we're going to draw a tree, kids, and blah, blah, blah. But some of you got confused with a factor tree because you would do numbers, a bunch of numbers on both sides of the tree. I start with a prime number, one of these, so that we don't have to grow the other side of the tree. So watch. Which one of these 5 prime numbers divides evenly into 24? 2. But what is the biggest one out of these 5? 3. So I'm going to start with the biggest one, which is 3. 3 times what gives me 24? 8. I'm going to circle the 3. It no longer grows because the only 2 factors are what? 1 and 3. So this one stopped here, but this one can keep going. What number of these divides evenly? 2 times 4, and the 4, 2 times 2. Bless you. So my factors are 3 times 2 times 2 times 2. Why did I write multiplication? Because if I multiply them, I should come up with the same number I started. 3 times 2 is 6, times 2 is 12, times 2 is 24. Let me do the same to 36. Which one of these 5 prime divides evenly? 2 or 3. I'm going to start with 3. 3 times what gives us 36? 12. So I circle the 3 because it stops there. How about the 12? Okay, 6 is not a prime. Which one of these prime? 3 times 4. Yeah, we started off, the first one has to be a prime. So 3 times 4. How about the 4? 2 times 2. So my prime factors are 3 times 3 times 2 times 2. Are we there so far? Okay. And then from there, your teacher said, okay, let's write them one on top of the other. We're going to circle the ones that are the same. Remember that? Okay, I'm not going to do that. I'm going to use a Venn diagram. Focus, please. Here we go. So, 1 potato, 2 potatoes. But here, instead of writing Michael Jordan, what am I going to write? 24. And here, instead of me, I'm going to write 36. So, question. What is the same here and here? What do they have in common? 1, 3, and how many 2s? 3 2s? This one only has 2. So this one, are there 2 over here? Okay, so this is the same as this, isn't it? That's what they have in common. Am I going to write it twice in here? No, only once. 3, 2, and 2. Guess what? That's what we call the greatest common factor. What is 3 times 2? 6 times 2? 12. Now, I need to find my least common multiple. Watch. What was left over here for the 24? For the 24, what was left over? 2. And what was left over for the 36? 3. Well, to find my LCM, my least common multiple, I have to multiply all these across that way. So watch. I'm going to do first these. What is 3 times 3? 9. And what is 2 times 2 times 2? 8. What is 9 times 8? 72. That's my least common multiple. Now let me show you a shortcut in case you don't want to do all that multiplication. Watch. Look up. What was left over for 24? The 2. If I multiply that times the other number, What's left over here for the 36? Let me multiply times the other number. Tell your neighbor what we just saw, please. Copy that, please. You guys didn't see it? For those of you that missed it, look up. What was left over here? 2. If we multiply that times the other number, what is 2 times 36? 72. 3 times 24 is 72. Or if you multiply all these all the way across, it's 72. Copy that, please. Example 2. Copy this. Okay, there it is. Example 2. You don't have to copy the instructions. Just write the numbers 12 and 18. Let's do this one together. Yes? Here we go. So write your first 5 prime. 2, 3, 5, 7, and 11. So we can keep those in mind because that's the first number that we need to start every time we find the factors. So we draw a couple of branches. Which one of these divides evenly into 12? 2, but the biggest one is 3. So it's 3 times what gives me 12? 4. Circle the 3. So like that branch doesn't grow anymore. How about the 4? 2 and 2. So circle both. So my factors are 3 times 2 times 2. Do number 18 by yourself. See what you get. Jesse, go. Where do I start? For 18. Times 3 times 6, and then the 6. 3 times 2. Very good. So therefore, this is 3 times 3 times 2. Hands if you got that. Okay, so we're done with that. Now let's draw a Venn diagram. 1 potato, 2 potatoes. Label this one instead of Jordan. This is for what? 12, and instead of me, this is 18. So, with red, what is the same here and here? 1, 3, and 1, 2. Both of them have 1, 3, and 1, 2, don't they? So therefore, that goes here. So my GCF is what? 6. Okay, so we're done with that. What's left over on this side? The 2. What's left over on this side? I'm putting a little times 3. So now we can find our LCM by multiplying all the way across or using the shortcut. You want to use the shortcut? So what is 2 times 18? 36. How we doing? Okay. And if you want to check it, let's see. What is 3 times 12? What is 2 times 3, 6. 2 times 3 is 6. 6 times 6 is 36. Either way. All right, do this next one by yourself. Example 3. Example 3, 45 and 36. 45 and 36. I'll give you a head start. Okay, let's see. I'm going to start with 45. Which one of these divides evenly into 45? 5 times 9, and the 9 is 3 times 3. So this is 5 times 3 times 3. Hands if you got that. Okay, good. How about this one? 2, but the biggest one is 3 times 12. The 12 is 3 times 4, and the 4 is 2 times 2. So my factors are 3 times 3 times 2 times 2. From there, 1 potato, 2 potatoes. All right, I'm going to label this one 45 and this one 36. So what's the same here and here? What do they have in common? 2 3s, or 3 times 3, and I'm going to only write it once and here. So my GCF is 9. Hands if you got that. Okay, good. What's left over for this side? A big 5. How about this side? 2 times 2. So therefore, to find my LCM, I multiply all the way across or use the shortcut. The easiest one is 5 times 36, right? So what is 5 times 30? 150. 5 times 6 is 30. So 150 plus 30, 180. Hands if you got that. Okay, we got this, yes? All right, let's take it up a notch, yes? Example Q. Ha 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 ha, no. Example Q. Whoa, let me zoom out. 20x cubed and 12x squared. And once again, we always have our 2, 3, 5, 7, 11. All right. Start with this one. Help me out. Maria, go. Yeah, because 5, okay, 5 times 4. And the 4? 2 times 2. Okay, so this is 5 times 2 times 2. We're done with a number. How about x cubed? How can we write it in an expanded form? X times x times x. You're like, oh, I know, right? Next one. How about the 12? Everyone. 3 times 4, and the 4 is 2 times 2. So this is 3 times 2 times 2, and the x in the expanded x squared is x times x. All right. 1 potato, 2 potatoes. This is for 20x cubed, and this one for 12x squared. So what's the same here and here? What do they have in common? 2 2s, and what else? And 2 x's. So 2 2s, 2 x's, 2 2s, 2 x's. But we only write it once, 2 times 2 and x times x. So my GCF is what? 4x squared. That is correct. What's left over on this side? A 5 and an x, so I write 5x. What's left over on this side? 3. So we can multiply all these to get the LCM. Or what would be a shortcut? The 3 times 20x cubed. So what is my LCM? 60x to the third. That is correct. Show me with your fingers how comfortable you are with these. Okay, not bad. One more? Yes? No, he's just looking at it. No. Yes. Example super cute. Example super cute. Be nice. Let's do 30 y to the fourth and 10 y. See how you do with that one. Bless you. Okay, I'm going to get started because we're not running out of time. This is 5 times 6, and this is 3 times 2. 5 times 3 times 2, and y. This is 5 times 2. So we write 5 times 2, and then the y. 1 potato, 2 potatoes. This is for 30y to the 4th. And this is 10y. What's the same here and here? 5, 2, and y. 5, 2, and 1y. 5, 2, and y. So my GCF is 10y. Hands if you got that. Okay. What's left over on this side? 3y to the 3rd. And on this side, nothing. So therefore, if there's nothing left over, look up. You put a 1. Because if you put a 0, it becomes 0, right? So my LCM is 1 times that, which is 30y to the 4th. Home play for tonight. Go to Google. And I want you to look up 5 pairs of numbers, just numbers by themselves, to find the GCF. And of course, now you know how to find the LCM, yes? And LCM. And then go to Google. Google GCF 2 numbers. Okay, GCF 2 numbers. And then they're going to give you 48 and 62, or 85 and 90. And find me the GCF and LCM, 5 of those. Then you're going to Google GCF monomials. GCF monomials. And then you're going to come up with these are monomials, aren't they? Yes? And then you find the GCF and LCM, 5 of those. 5 pairs of these and 5 of numbers. Enjoy your home plate, guys. There's no tuning today. I got to go. Have a good one. See you guys tomorrow. Bye.